Economy and energy are close connected. Without energy, there will be no economy. And most economic experts are not aware of this. I would like to talk about the energy resources and energy management for sustainable development. Before we start, I would like to put on the table 10 questions for the answers. You should know these answers at the end of the course. The problem is how the energy use how to energy use influence our quality of life. What about fossil fuel lifetime? What will be the role of nuclear or renewables in the future? To what extent our lifestyle influence the use of energy and planet's environment? Everybody's talking about this now. To what extent could we reduce any adverse environmental impact from the energy use? Can or should developing world adopt Western world consumer society style or energy use? This is the most important question. If the China will have the same quality of life as we have now, the all energy resources will be not enough at present for the China only. That's the question of the development of China and India. Can developed world cut back its level of consumption and use of energy, consumption of fuel and use of energy? That's the question. What will be the future energy development? Which way we can go? What are local and global actions which can secure sustainable future with regard to the energy? Should we differ between quantity and quality of energy? I don't know if you know what is the quality of energy and what is the quantity of energy. I will show you. I will start with definitions because most of you are not from the energy fields. Then I will talk about the energy and quality of life, population growth and energy needs, consumer society and energy use, environmental impact of energy use, some words about the energy resources, about the energy management, what can be the energy system for sustainable development, and conclusions. So what about the energy? What is the energy? Who can answer me? What is energy? No? No, what?
Without energy, we cannot live.
What? Yeah, yes, for sure. Without sun, we cannot survive. But energy, the answer is not so simple. There was one PhD doctor, very old, one professor, which stayed 1 hour before the commission, not able to answer what is the energy. There was only one question for the PhD. And that was the big problem. Energy, at the end, all form of energy. We know different forms of energy. Wind, water, hydro energy, fuels, fossil fuels, nuclear energy, etc., potential energy, and so on. At the end, all forms of energy ended as heat. And heat is transferred from the earth in the space. In the space we have the temperature which is approximately minus 273.15 Kelvin. So the energy is flowing in the space from the earth. So this zero, absolute zero, is the measure, and if we have the energy above this absolute zero, this energy have some quality. But if you have the energy above the environment you are living, this energy from the environmental temperature to the zero is useless. A name for this part of energy is anergy. This is the energy below the temperature of environment. Then we have one part of energy which is highest, in the highest level above the environment. Burning the fuel. The temperature of the flame is about 1200 to 1300 Celsius. So the fuel have something else. This is exergy. Because if you are using this heat of the fuel, you can run the turbine, you can run the motor in the cars, you can do many things, you can do work. And this part of energy, we are saying exergy, from the Greek exergo, and this is the energy over the temperature of the surrounding. And in practically, we are not buying any energy. What we are buying exergy. We are selling exergy. Fuels, etc. This is pure exergy. Solar energy is pure exergy. And problem is that we convert this exergy with our machinery on the thermodynamic way or some other way, mechanical way, and we are losing lot of exergy, and useful energy is only small part of exergy. If we are looking on the power plant, you put in the power plant fuel, 100% of exergy. Outcome is electricity. Efficiency is about 35 to 40%. 60% of exergy in the fuel we are transporting through the cooling tower or cooling water in the environment. And that is the problem, because using the energy, the exergy on the proper way, it will be, this is also some kind calling sometimes efficiency of use of energy. But what is important only this, that you know that energy have at the end is all energy is converted in the heat, even the work, even the mechanical work. At the end you have the heat. And if you compare this heat with the absolute zero, then you have one part which is energy and the one part which is over, this is the exergy. And we are buying, we are selling, we need only exergy. And the exergy is the measure for the quality of energy. 1 liter of the hot water, they have about 0.6 kilowatt hours. 600 watt electricity can be used to run, I think so, one computer for 5 hours. With 1 kilo hot water, you cannot run the computer. But the amount of energy is the same in these cases. So we have to make the differences between the quality, and the quality of the hot water is low exergy energy. Electricity is high quality energy, is full exergy. And this is the difference. What is still important, many books, many politicians and many professors are talking about the consumption of energy. Dear colleagues, energy cannot be consumed. Energy can be only transformed in one or other way. What we are destroying, what we are consuming, is the exergy of energy. Only this part can be destroyed. About the units, we have the watt, kilowatts and megawatts. This is the measure for the power. This is the possible capacity to do work. And energy which is converted is work done, is the power multiplied by time. So that we have kilowatt hours, we have kilowatt, and this is difference. And joules are normally used. This is a very small unit, and you should know that this is the measure for the energy which is converted. Okay, I have been talking about which form of energy we have. Especially for us are interesting solar energy in all forms, geothermal energy, and planetary energy, because these three types of energy are for our civilization forever available. We are talking about the primary, secondary, final, and useful and rejected energy. Primary energy is solar energy, geothermal, tidal, fuels. Secondary, we make from solar energy, from geothermal, from fuels, electricity, gasoline, and so on. In between, we have the losses, which are different from different technology. Final energy is the secondary energy in my house. Between the power station and my house is transformer, are the lines, we have losses. And useful energy, if I am heating the room with electricity, for me is useful energy heat, not the electricity. Okay. Energy and quality of life. There was a lot of discussion about how many energy people need to have a very good life. If we take the statistics from 127 countries that was made by World Energy Congress, we see that the achievable lifetime for different people, women and men there is different, is depending on the energy. If we have low energy available, the lifetime is short. Then it's going very fast up, and after the certain amount of energy, their growth is, because of biological reasons, is not more so high, 70 to 80 years. Without regard if you have 4 ton oil per capita or if you have 2 ton oil per capita. And these differences are the consumer society. So we are not changing so much the lifetime, but we are changing the use of energy. Slovenia is here. You show we are using about 2 ton oil equivalent, and our lifetime is here, is much higher little even as United States, which is here. If you are looking the second part, this is the death of the newborn child. If you have no energy in the society, this means your social status is very low, then the debt is high. Then you can have, if you have a lot of energy, then this means that debt is lower and lower and lower. But then they stay on some level about 3 to 5 person per child per 1,000 newborns. But you can see that even if you have low energy use, like Slovenia, our medical system is so high that we are under the average which we have in the most developed country like United States, which is here, or Canada. The same is with illiteracy. Okay, we know. This is the same case. No school, no energy, no school. You have the energy, you have good schools, you have very well educated people. What is the resting? The most developed country have less education as normally the country in the middle. Here is the Europe, and here is the part of United States and other developed countries. Why is the reason? This is the reason of the distribution of the capital. But in any case, the education, the quality of life is depending on energy, but what you can see, there is some limit which can give you possibility to have the high quality of life. And this limit is about 1.6 to 2 ton oil equivalent. And now you can calculate if you have 2 billion, 2.5 billion Indian and Chinese, multiplied by 2 ton oil, then you can see how many energy they need to have their high quality of life. That's the problem. Population is growing, energy is growing. What will be the evolution of the future use of energy? Nobody knows. We have so many scenarios, so many good, so many bad. The developed countries have decided yet to change the energy system, but only partly. United States are still for the coal. Nuclear is open question. Gas is coming, but the gas resources are limited. If you are looking here, the maximum of the use of oil is behind. Coal, use of coal is going down because of the environmental problem. But the amount of coal on the world is much, much higher than all other type of fuels, gas or oil. And the coal, oil and gas are just accumulated solar energy in the past milliard of years. So nobody knows what will happen. Yesterday I have the information that for the moment in 2007 on the world population is 6.7 billion. The curve which is here is quite real. So that this means that at the end of the century we will have 10 to 12 billion of people. How to supply the energy to these people? How these people can live? Nobody knows. I can answer you. The only way is to go back to the sun, to use the sun. What is also interesting in this diagram, you can see that with the time, the share of the different fuels is changing. In 19th century we have biomass. Then we have in 20th century coal. Then come in end of the 20th century come oil, gas, hydro is almost constant. Here is the nuclear, a small amount, so many discussion about the nuclear power. But amount the nuclear power is covering our energy need is relatively small, less than 16%. And this mixture here must change because some people say CO2 is the problem and the fossil fuel are emitting CO2. How to change these things? We will see. The next bad things we have in the world is that the richest 20% of population is using more than 55% of final energy. And 80% of global population have available less than 40% for the moment. And this is the problem. And 70% of the electricity is produced in the world which is developed. But we know that without electricity there is no development. I will go next picture. What are the energy resources on the world at the present? What we know. Our consumption at the present is about 13.5 zetajoule. Zetajoule is a big unit, is 10 to 21 on the power 21 of joule. This is equivalent of 24 billion ton of oil equivalent. 1 zetajoule. Then this means that we are using about 250 to 300 billion ton oil equivalent in the last 100 years. Reserves. Total reserves are about 48 zetajoule. Resources. Reserves are the part of the resources which are discovered. We know what are there. We are thinking that resources which are available on the world, on the earth, are about 238 zetajoules. This is for approximately 1,000 years. If we are talking also with the resources which can be developed in the future. But oil, everybody agreed now the oil will be after 60 to 80 years finished. We have to change our cars to some other fuels. Gas are plenty of the gas are still in the world, especially if you look on the methanhydrat. This is the new type of the gas which is in the deep sea, is white, methane connected with the water under the pressure, and if we are burning, this is the new fuel for the next century. Yes, please.
I was wondering the last slide.
Yeah.
Is that with
This one?
with the growth potential, or it's covering just now the 60 years? Is that the
In 1998, we have been using 0.31 zetajoule. This is about 70 million ton oil equivalent. These are the reserves which are proven. We know for this reserve where are on the earth. Resources, geologists are thinking that this is the total reserves which are not yet uncovered, but from the geological point of view can be these resources, because normally we are finding from year to year new resources. And the base is still a little bit higher, because there can be resources we don't know now, but they have saying there must be more coal. You see, the reserves of coal now known are 21. Resources which are approximately a little bit, how to say, more known, 172. Possible resources, 200. Altogether, a lot of them. All these resources cannot be exploitable. That's the problem. And we know that we have limitation for the exploitation of these resources. Most interesting is the gas. Gas is the fuel for the future, but also the methane is the fuel which can be used for the next century, of course, without problem of CO2. Yes?
What about hydrogen?
Hydrogen.
Is it in gas or?
Yeah, hydrogen is in gas. Methane is one carbon for hydrogen. But you have to produce the hydrogen. In the nature, hydrogen is only on the sun, and in the nature we don't have them. So you have to split the water. You need electricity for hydrolysis. You can split the methane. You need the energy.
Yes, the energy gain is still very high.
No, no.
Energy gain, yes, maybe the costs are not sustainable.
Hydrogen is energy carrier, is not the fuel. Many people made the mistake. Hydrogen is energy carrier. This means we can store the energy in the hydrogen. But if you would like to use the hydrogen, hydrogen is very volatile. You have to compress them to 200, 300 bars. If you would like to have the liquid hydrogen, you have to go to minus 220 degrees Celsius. You need a lot of energy to cool down and to compress. And to practically use of hydrogen, they are starting, but there are so huge problems that you cannot imagine if you look how the hydrogen is transported from Canada to Cape Canaveral with the cars, with the cisterns, and if they are tanking the liquid hydrogen, the air is condensing on the pipes transporting the hydrogen from the reservoir to the cars, to the trucks. If you can imagine the jumbo jet, which need 150 ton of kerosene per one flight, there must be about 300 ton of the liquid hydrogen. Can you imagine how to fill these things on the airport? It's not possible. But hydrogen can be used for the synthetic fuels. With the hydrogen we can make, as I will explain later, methane and methanol. And these two types of the fuel can be used in our present system. I will talk a little bit later. Yeah, global potential of the renewables. Renewables, current use of renewables is 56 exajoule. This is 1,000 times less. But our theoretical potential of all renewables is much higher than 144,000 zettajoule. If we compare with the fossil fuel, all energy we are using now in the world is only 10,000 part of the energy which is coming per year from the sun to the earth. So we need to convert only 1 through 10,000 and we have enough energy for everybody. And that's the problem, how to convert these things and how to obtain the capital to do this. We have the technology, but the efficiency is a little bit lower and the cost of the fossil fuel is much lower than the renewables. Energy conversion technologies which we have now present in the world are different. Normally, especially interesting are the technologies for the production of electricity. Because the electricity is the one of the most important energy carrier, because it's very simple to use and can be converted in all kinds of other forms of energy. Mechanical energy, heat, what do you like? With electricity you can do everything. With the hot water, not. No, and we have here the technologies. Here are the conventional power plant and proposal from the researcher and developer is that this type of classical power plant will end with the new design and to build the new power plant until 2020. And after this time, we have the new technologies. Integrated gas combined cycle with the carbon removal. Integrated gasification combined cycle. Hydrogen production for the synthetic fuel. Fossil fuel cells. They will coming after 2030, not tomorrow. And then we have different other types, but there is no nuclear energy here. This is the interesting. This is not my idea, this is the IASA analysis. Why not? Because the limitation of the use of uranium, which can be used for the nuclear weapons, and also because of the waste. We don't have now the technology which can be used to transform the high radioactive waste in the low radioactive waste. And that's our problem. If the science will find the way how to do this, then the nuclear power will be interesting also for developed countries, not for developing. Yes?
In France, they have like a big process going on with, I don't know the difference, but making the
Yeah,
fusion?
fission. We have the fission plant now in France. 75% of electricity in the France is coming from the fission reactors, uranium reactors. They have built one reactor which is the breeder, which has built to be able to use the used fuel from the fission reactor in the breeder and to run and to have more fuel and so on and so on. But the power plant has been stopped because technology is too dangerous and the problem is so high that the Phoenix 2000 is not running, as I know. Second, we are making ITER. This is an international fusion reactor. They will cost about 5 billion euro, and after 20 years, after build this unit, we don't have even 1 kilowatt hour of electricity from this installation. That's the problem of development of this type of nuclear power plant. You have? Okay, thank you. So nuclear will be still here in this century, but you know, not in all parts of the world. Developed country, they can have the nuclear power station, but the country which have unstable society, nuclear power plant cannot be there. If there come to some revolution, you know what's happened. Even in Russia, which is a relatively stable country, they have made the problems. And if you can imagine the nuclear power plant in Iraq, if they have now. Even in China, they are building a lot of them, but nobody knows what's happened after 10, 20 years. That's a big problem. Technology, conversion technology, which are coming now, are always cheaper. But what is interesting, I have the data here for the solar photovoltaic solar cells, PV cells. You can see the development of the price, which is coming very fast down. It's not yet competitive, but is coming very, very fast down. In the next lecture, I will show you where we are, but in any case, we are coming down. In 13 years, 14 years, it will be much better. But only one technology, this also the cost of the gas power plant, coal power plant, all these costs are going down. But only one technology is not cheaper. This is the nuclear technology, because the environmental problems. If you are building the nuclear power plant, you have to fulfill so many environmental requests that the costs are coming up. Of course, there is only one technology, but I think so this is not always the question. In China, these costs are not so high as in France, because the environmental requests are much lower than in Europe. If you are looking at the classical technology for the conversion in the homes, in the buildings, we have quite high technology conversion efficiency. 85 to 100% for the condensing boilers. Power plants are coming to 45 to 60%. Cars are going down to 4 to 5, Prius to 6 liters. Diesel engine are very efficient. Electric bulbs, they have efficiency 50 to 65%. But the new technology with the light emitting diode, efficiency come up to 70%. So this development is very high. Air conditioning is coming up with the heat recovery to 90%. But still, because we are using more and more energy, even with this efficiency, the growth of energy use is quite high. What we can use for the replacement of fossil fuel is the question. Wind energy is growing very fast. We have no problem, except the wind is not always available. PV growth is very high, the same problem. We have electricity only during the day. variable electricity. And the rest is, of course, the classical type of the fuels. Solar energy. Solar energy in the buildings are chance which can be used everywhere in the world, especially for developing countries. Solar collectors are relatively cheap, simple to build, everybody can build, there is no dangers for the use for the weapon, and up to 80% of the heat needed for the hot water and heating of the buildings can be at present supplied by new modern solar system. There is only one condition: the building has to be built a little bit different as present here, with the glass wall, low insulation and so on. So heavily insulated buildings can be used and can use the solar energy. %70 of all energy is going for the heat. 40% of all primary energy in Europe we are using for heating and cooling of the buildings. We can build now the buildings which can have 10 times less energy use as normal house built in the 50s or 60s. Here you can see the here is the shape factor of the building. Here is shape factor 1, mean that the volume of the building is the same as the outside area. If the volume is lower or bigger, then the shape factor is changing. But normally the 4-story building shape factor is 0.5. Here are different conditions what is allowed heating load in the buildings. In Slovenia, Austria and so on, the heating load is about 8 watt per cubic meter. If you are looking on the energy efficient building, it's only 4 watt per cubic meter. If you look on the low energy building, which is now built in different countries, there can be also lower. Passive energy house, this means which is heated mostly from the sun, there is no needed any other type of energy, can be as low as 1 watt per cubic meter. Okay, we cannot build all houses as new houses with so high efficiency. Also we have stock of houses presently here, many millions of them. And if we go to the refurbishment of these buildings, we can come from the 10 watt per cubic meter, can say, to 4 or to 3 watts. It's 3 times less. So that is 40% of energy used now for the heating and cooling of the buildings can come down to 15%. And this is the goal which was accepted also in the European Union by the new legislation, or not the new conclusion of the Council of the Europe. They say 20% less primary energy, 20% of renewables. How we can use the energy with low exergy in the buildings? Normally the buildings are heated with warm water, 90 degrees Celsius, 50, 130 Fahrenheit and so on. If we are using the floors or the building construction, and if we put in this construction the pipes, we can heat or cool the building with the temperature of the water only 30 degrees Celsius. And there is no problem in the winter with the solar collector to heat the water on 30 degrees Celsius. It's a problem to heat to 90 degrees Celsius. So these are the buildings, new buildings, which can be used, which can use the heat with low exergy, and we are calling this low exergy building. In the floors, and so we are building in the middle the pipes, plastic pipes. Here come the water, low temperature water, 30, 25 degrees, 60, 22 for cooling. And of course, the energy load is about 25 watt per square meter. This means about 3 to 4 watt per cubic meter. Here is the practical design, practical experience how to build these things. Also the big towers can be built on the same thing. These type of buildings can be heated by sun without any problem. In the winter, in the summer, can be also cooling. Yes?
What happens if you don't have the sun for a week, let's say, you have a rainy period?
Yeah. Then you have the additional system which can be supplied by gas, by oil, or in the modern system by pellets. Because the high efficiency buildings need very low amount of energy for the heating. And if we are using the pellets, the modern heating system on the pellets is comfortable like the oil or gas, and we are using biomass. And this is the totally sustainable system. Of course, if you have the large system in the town, you can use also the district heating as the supply, secondary supply, and this district heating can use waste, incinerated waste, or also the biomass.
But would these buildings then need a secondary system to heat up, or it's a switchable system?
A switchable system. Normally we are using switchable system because only the generation of the heat is different, and the cold, of course. So that we supply in the same system cold water, hot water, only the generator must be different. And so, for conclusion, we can build now in Europe 7 to 10 times more efficient buildings. If we are doing this in the world, in United States there are big competition between the large companies to build LEED buildings, low energy buildings with special points, and the big companies like the supermarket chain, what is the name? Walmart, yeah. And then the banks are building the new supermarket or new buildings with the LEED number 10, 20, and so on. So that they're coming with energy quite low, down to 1/10 of buildings like skyscraper in the New York. Renewable energy technology. Renewable energy technologies which are now in high development, first are the wind generators. Now we have able to generate electricity by this wind generator what we would like. There is no more limitation. The first type of wind generator have the problem. How to connect with the grid, how to work with the grid, if the wind is there, if the wind is too strong. Now the modern technology is overcoming all these technological problems. And you see here is this is the wind generator before the Copenhagen. Similar now we have in the at the end of the river of Thames, there is 130 megawatt of such unit. And this unit are growing, still growing. From 1980s to 2003, the first small wind generator was 50 kilowatt, 15 meters was the tower. Now we have the towers 160 meter. The power is 5 megawatt on the top of the tower, and wing we have more than 60 meter long. Here is the middle part of the wind generator of 2.5 megawatt. Can you see how big is this middle part? And here are the wings. One wing can be can have weight 70 ton, moving slowly around 12 RPM per minute. And generator, which is on the top of the tower, the weight of this new type 5 to 6 megawatt units is about 210 to 350 tons. Can you imagine that you have put up on the small tower this weight? This is working very well. And the last time in Germany we have a very big wind. There was last October, I think, so there was 180 kilometer per hour wind across the Berlin. And there was also just the new 160 meter long, large tower with 2.7 megawatt unit. Nothing happened. Everything was surviving this big wind. I'm sorry. No. Okay. How we are building this new big units? The technology is changing. We have now carbon materials, we have the different other plastics, and now we are building any type of wind generator without any problem, up to 6 megawatt per unit. You see how big is this? Here is the man, which is going up, and this is not the biggest one. This is only 2.5 megawatt. If you go to 5 megawatt, it's a little bit much higher and bigger, and we are transporting the towers with the cranes in the ships on the sea. And this is the technology which is here. Oh, here you can see, this is one wing, very nice. Here is the connection with the wings. So that you see, this is the, like at the end of the airplane you have these wings to lower the noise of the wind generator. This is the technology which was developed in the last 10 years. What we can expect in the next 10 years? It will be much more developed for the renewable energy, as you can imagine. Here is the factory. You see, here is the one of the 2.5 megawatt unit. People is here and it's working on the top of the tower, 120 meters. Inside of the tower, this is the about 6 meter diameter. You have the lift. You can transport. You have the personal lift to come up and down. There is no problem. This is a nice technology. What is the plan for the wind generators? Yes? Yeah.
But there is still an impact on the environment.
Yes. Yes.
And like it's not nice in the landscape to see it, so and it makes noise as well. Like you have the shadow. The blinking.
Yes.
How efficient are
But can I ask you, do you have some big problem with the cars on the street?
Yes.
Running around?
Thing, I guess.
Yeah, but you are still using, you are not fighting against the car in the street. But many people is fighting against the wind generator in the field. Nobody's going, car are coming, whoo, noise, and so on. Yes, you are right. We have the impact, but this impact, in comparison with the other negative impact we have with the power plant, with the nuclear plant, with the transportation, you can make the evaluation. What is better? To emit many tons of CO2 or to have a little bit blinking wind generator? It's the question of the value. Please.
and how much energy is needed for producing it? Are there
Yeah.
life cycle analysis?
Yeah. I have been escaping this part. It is about in the less than 3 months. the energy produced by normal wind generator is enough to cover the energy for the production of the material and construction of the wind generator. Even if we use this first design with the steel towers, because after the steel towers is put it on the place, then we have the fundament, and this is very heavy concrete fundament, and this stay normally in the earth because nobody will take this out, and this impact is very negative. But still, if we are taking this and we are talking about the birth to the death life cycle cost analysis, the wind generator at the present very, how to say, environmental friendly system, more than the hydropower plant. Hydropower plant impact on the land, on the other things is much higher than for the wind generator. And the Europe will go with the wind generation on sea. And I show you here the North Sea plan for build 10,000 megawatt wind generators. 40% financed by Great Britain, 40 Germany, 20 Netherlands. This type of the units in this generation will compete with the gas. OECD plans for the European Union is 10% wind generation. In 2050, we expect we will have 1 million megawatt power with the wind generators in European Union. In China, there will be a lot of them. They are building 10 per day. Small units, but 10 per day. They are built 2 power plants, about 1,200 megawatt per month in China. You can imagine how many buildings is, yes?
We're talking about this number is 2.5 megawatts energy. Can you please give a comparison of how much energy that is? For example,
Aha.
how kind of big building we can...
Yeah, power of 2.5 megawatt. You can compare this with electricity consumption of the town of about 10,000 people. 10,000 homes, about.
If the wind is blowing, right?
Yes, you are right. Normally we are calculating with the power plant wind generator to work 2,000 hours per year with nominal capacity. This means that for each megawatt of thermal power plant, you have to build 3 times more wind generator. Because the normal thermal power plant is working 6,000 hours per year. Normal capacity. This is true. Yes?
For now, the numbers up there, this is with the oil price, but today, the oil price is really high. But
Yeah.
when it goes down again,
Never.
still covered?
I am sorry. I am sorry. If you hope that oil will be cheaper, I will be very happy and I will give you something. Just to explain me how you can, from the economic point of view, if the resource is lower, never be cheaper. It will be only more expensive. 3 years ago, I have been talking with our specialist for the petroleum company, and I have told them, gentlemen, there was oil was about $22-23 per barrel. I say, gentlemen, in 1 to 2 years, the barrel will be 40. And they say, you are stupid. That's impossible. There will be never. Now it's 72. 72. I have been expecting that in January next year will be 100. And then you have completely different economic situation with the renewables. Therefore, if we are now we invest in renewables, at the present the payback time is long, but always will be shorter and shorter and shorter, and competition will be doing, and I hope so that this will be happened in the 50 years, because not before. Yeah. Here is some data about the wind generators. There are a lot of discussion about the quality, environmental impact. In Slovenia, we have no one wind generator because the people is against. All the places where the wind is blowing in the high level, because Slovenia is hilly, so we have to go on the mountains. Everywhere is the Natura 2000. So we cannot build, and we have big fight. But if you compare the really impact, look, in the United States, death from the coal generation 159. With generator, there was no death until now. If we exchange the power plant, coal power plant, with wind generator, emission is 99% lower. If we exchange with combined gas power plant, emission is still 98% lower. Influence on the birds, that's the biggest problem in Slovenia and even in the Europe. How many birds are dead? If you compare the death of the birds from the wind generator in California, where it's very, very strong, big amount of wind generator, and with the birds which are dead because of the car, the result is here. There is no comparison. There are some deaths, of course. There is no zero. But how many deaths are by the cars? We in Slovenia, we have about how much? 1 million cars altogether. 2 million people, 1 million cars. Trucks and normal cars. And we have about 500 deaths per year because of the cars accident, and we have about 5,000 injuries. Can you imagine one nuclear power plant running in the Europe, which have 500 deaths per year? Never. Even one, everything will be closed. So it's opinion of the people. In one side is no problem, on the other side is a big problem. The same is with the wind generators. There are some problems, of course. There is no people activity without impact of environment. Therefore, I am talking not about the conservation or preservation of environment. I am talking about the management with or in environment. Solar energy, solar cells. Solar cells are the very simple equipment. We have the plate of silicon. On this plate we put some layers, thin layers of semiconductors. Then we put the glass over these semiconductors, and we have some electrodes, and photons are coming to this surface, and they're shooting out the electrons. Electrons are going in one side, the other side they are going the empty places, and so the efficiency of the present solar cells is 17% maximum. This is the Japanese technology. Normally is 14 to 16%. At the end of 2010, the United States are promising to have the efficiency of 50% with the multi-layer cells. Hydrogen and fuel cells. Hydrogen, here is the possible technology for the hydrogen. Solar cells, solar power plant, hydrogen, water destruction, hydrogen storage, and distribution of the hydrogen to the end users. And here is the fuel cells. Fuel cells are simple. This is only the battery. Each battery is using hydrogen. Only this hydrogen is connected with some materials, and if the hydrogen is used, the battery is empty. The fuel cells is the battery in which we are fueling the hydrogen always continuously, and air so of the other side, and we have the oxidation. And the problem of the fuel cells is lifetime. There is no fuel cells with a very long lifetime. Membranes, electrodes. And we have now big development. I hope so after 10 years, 15 years, we have the big commercial production of fuel cells, but not before. Solar power plant. This is the future. Solar power plant can be built. Solar cells are small units. Solar power plant can be a large unit, megawatt units. This is the parabolic true solar plant. Here in the parabolic true, we concentrate the solar radiation to about 400 degrees Celsius. We have oil. Oil is heating heated water. Water is becoming steam. Steam is going the steam turbine, and we have the standard thermal power plant. Only this part is the solar. We have the storage. Without storage, solar thermal power plant cannot work well. The other type is the solar power plant using the heliostat. This is the big mirror, 40 square meter, moving according to the sun, so that the all reflection are coming together in one tower. Therefore, we are saying this is the solar tower power plant. The same principle, here in the tower we have the temperature about 900 degrees Celsius. Even more, 1000. There is no problem. Only problem is to have the place to put these mirrors on the earth. Here is the sample. Yeah, there is also one type of energy which can be used for the heating of the homes. These are the heat pumps. Heat pumps are using the electricity to run, but they can use also the heat from the surrounding. Water in the earth, water or the heat in the earth alone, and so on. About the energy system for the future. Yes?
Just one question. What about geothermal power plant?
Geothermal power plant are also very actual, and there is only the question when we can build this and how much. Deep wells are very expensive. Normally you have the temperature of about 150 to 170 degrees Celsius if you go deep 5,000 to 6,000 meters in Europe. And
What about using, for example, in Slovenia, the existing deep boreholes that are in the eastern part of
Yeah.
Slovenia? They're used for
we have lot of these, but all these wells are about 1,000 meters, 1,200 meters. We have only one well which is 4,000 meters deep in Blutomer, and this can be used. But all these wells has been made to exploit for the gas and oil, and these are not clean, and that's the problem, because you have always some mixture, and if you have the oil and water, then the system is not working well. But now is in the plan to build this, from my proposal, 13 geothermal power plant, each of 30 megawatts should be built in the northwest of Slovenia.
And the energy of waste.
Energy?
Of waste.
Yeah.
Is it possible to accomplish?
Oh yes. Oh yes.
In Portugal, we are installing the system to treat energy.
Everywhere in the world has waste incinerating plant. combined with the heat production or electricity production, and at present even the cleaning of the waste gases is not more problem. And this is the one part of how to use the renewable energy. Only we have always the problem with the people. Nobody would like to have the waste incineration plant in my backyard. That's the problem. But in any case, this waste is not so much. You know, with the new technology, recycling, reusing, the energy composition of the waste is becoming less and less value. Yeah, waves, not waste. Waves, ocean waves. Okay. Yeah. 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 But before you have the wave, you have to have the wind. So, now is the question, technology for the wind is major. You can use for the waves, we are still developing, and there are a lot of problems. We have these floating things and so on, but there is the question of future development. If you have not the deep sea, and if you have the wind, it's better to put the wind generator.
Like I said, unfortunately, we are going to try to.
Yeah, I know. I see this installation. It's a very nice, and I hope that it will be working. Yeah, go back. Present energy system. Before I conclude, the energy system which we have now. We have fossil fuel, we have some uranium, and we have solar radiation. Everything we are using, we are converting in different forms of energy, and in the final energy, we have the gasoline, we have the gas, we have the biomass, we have the heat, we have the electricity, and so on. Everything is here, everybody is competing with each other, and we have free market of energy. Everybody is introducing the energy market. And somebody tell us, I don't know if Professor Menzinger tell you how market is influencing the prices. And according to the theory of the market, free market, the price of energy should go down. Why not? Something is wrong with the economy, with the theory. We are now the market for the electricity. Free market. Everybody can take the electricity from everybody in Europe. I can ask for German electricity and they have to bring me this electricity. But the price is not lower. The electricity price will go very, very short time up. Because the market is not working for the goods which are not available in quantity which we need. And therefore the French people say, there will be no market for the electricity in France. We have only one owner and we will sell electricity according to our politics. Because if you don't have the electricity available at the moment, all industry is stopped. All heating system is going away. Even if you are using biomass, in the old times we have the stoves. You put the biomass in the wood part in the stove, and the stove is working. Now you have the pellet, and the pellets have the burner, and the burner has the fan and need the electricity for the control. If the electricity is out, your biomass system is dead. So therefore the electricity is becoming so important that nobody would like to have free market on this field. Even Germany not. There are 3 companies playing on the market, and the poor people is thinking that there's the free market of energy or electricity. Yes, this. Yeah. New future sustainable energy system should be built in the next 40 years. How? we should go out of the fossil fuel to the renewables. We can use the planetary energy, we can use solar energy, water and air. With the solar energy we can produce electricity. With the electricity we can split the water in the hydrogen and oxygen, and we can convert these two, the hydrogen in methane and methanol using the biomass, carbon, which is in the biomass for the synthetic fuel, and the end consumer, the final energy, will consist only from three main sources: electricity, methanol as the liquid fuel for the oil engines and so on, can be stored as long you would like, and the gas, methane, and we can use all the present infrastructure in the world for this new system. If you go to the hydrogen economy, you have to change all the infrastructure if the hydrogen will be as end-use energy here. Here is only one energy which is not shown. This is the heat. If we have the district heating plant, then we will have also the heat as one of supply possibility. But in any case, this system is sustainable. There is no emission of CO2, there is no pollution, it's clean, water from water, hydrogen from water, solar energy is always here, and the methane and methanol are only the way how to store the solar energy for the time sunshine is not shining. Yes?
Remember well, in Brazil and USA, we're going to develop like an economy based on fuel from food, like ethanol.
Yeah.
You didn't mention that.
No.
Why?
Simple, because this is intermediate stage. It's a supplement to the fossil fuel, 85% of ethanol or 15% or 5 of biodiesel. Because ethanol, we have 6 carbons and 6 hydrogen. In methanol, we have 1 carbon and 4 hydrogen. From the environmental point of view,
Ethanol is
2
2 carbons.
carbons, C2H, yes. C2H4, yeah. 2 carbons and 4 hydrogen, yes. Then we have 1 carbon and 4 hydrogen. This is true. And to produce the methanol, you need less biomass and the same amount of hydrogen. To produce the ethanol, for the moment we are using only the corns, the grains. And we have to develop the new system to use all the plants, to convert all the plants in the ethanol. I am not against the ethanol, but this is only from my point of view, one fuel which can be very seriously used in the future, but you have to have lot of plants.
But that's what is happening in America and Brazil.
Yes.
They are using
But they are using in Brazil a lot of the rain, sugar, but also the rainforest. They are cutting the rainforest and they are growing the sugar cane. The problem of environment is only if I go back. Oh. No. No. I have a moment, sir. Yeah. Here, we use the water to produce the hydrogen. And we are using only one carbon from the plants which are available, not to grow spatially from the waste plant. And still we have some hydrogen in the plants. So we multiply the system and we have more fuel. If you go only to the plants, you have to grow this. You have to use the fertilizer because the plants are not growing from himself. Mr. Lobnik will tell you how much energy you need. Even if you use all the plants on the forest, you have to cut the forest. And then, because amount of the fuel you need in the world, if you compare to amount of the forest available or the plants available, there is no comparison. You need more hydrogen from the other source. Therefore, I think so this is the intermediate fuel. But now we have still the complaint of the people in developing world. We don't have food, and you are working and you are doing from the grain the fuel. Give us the grain for the food.
May I add that the European Commission last month decided that the source of energy from plants should be reduced. Even 1 year ago, they said that one important issue would be biofuel. But now they decided that this should cause an issue in the world market, and also it is not sustainable. It is true that in Brazil now are converting 1 million hectares to produce biofuel. But as Professor said, it is an intermediate period where we don't find something better. Because plants are also taking water. For 1 kilogram of dry matter, it needs 500 to 1,000 liters of water. It goes through the plant as transpiration. For 1 kilogram of dry matter.
Yeah.
So shortage of water in the world
Is the biggest problem.
tremendous. So if those climatic changes will be not favorable for growing plants, which means even more water will be needed for plant production. But 9 billion people will not starve. They want to eat. So the number of population is growing tremendously. But it's true, intermediately,
Yeah.
this is one of the sources.
Yeah. Now I would like to conclude energy use and consumer society are not sustainable. Consumer society is using too much for nothing. We don't need so many things as we are buying. Advertising, every day the people become the information you need. Here I have the stone if somebody is sleeping. Everything. We are buying stone for the new year, you know, imagine some years ago in the United States and so on. Consumer society is not sustainable. Fossil fuel have the finite lifetime. Nuclear energy is transitional solution for the developed countries. Renewable energy sources are sustainable, but at present not economical. Energy efficiency and wider use of renewables energy sources can be way out of expected energy crisis and global warming which is present now. Thank you.